Hi, and welcome to Allen High School's pre-AP chemistry discussion of solutions. And we're in the midst of looking at the dissociation of ionic substances. Now let's take a look at our first example. We have sodium carbonate dissolved in water. Notice we don't bother putting the water in the reaction. This would be a solid on the left-hand side, and since it's dissolved in water, we put aqueous. Now, I want to explain what this I equals 3 is. It's the number of particles or ions that are in solution. This is going to come into play a little bit later on in our discussion. So let's take a look at how we're counting 3. Now, when this is together, I have 2 sodiums bonded together. I'll just kind of overlap them to show that they're bonded, and a carbonate. Now, when we've bonded things, when we're counting things that are bonded, we have 1, 2 sodiums, so those are right there, and then we have the 1 carbonate. So when it's bonded, we use subscripts. Now, when they dissolve, on the other hand, they're pulled apart from one another. So we have a carbonate, and we have 2 sodium ions. Okay, the black represents the sodium ions. Now, these are now separated from one another and surrounded by water. They're hydrated ions. And now they're not bonded, they're separated, so we're counting 1 carbonate and 2 separate sodium ions. So that leaves us with a total of 3 particles. And this shows an example of dissolving sodium chloride, just so that you see how the negative, remember water has a partial negative, it's polar there, and each hydrogen has a partial positive. Overall dipole moment that is positive on this end and negative towards that end. And so what we see is that for the positive sodium ions, the little negative charges on the water are surrounding it, and for the negative chloride, the little positive parts of the water are surrounding it. And notice also that there's more than 1 water attracted per ion. It's not 1 water molecule per ion, but there's more than one water molecule there. Okay, can't talk, I guess. Okay, so let's take a look at how these dissolve. And what we want to do is move into discussing some of the properties of these. So this is lithium phosphate. The first question is it ionic or covalent? And it is ionic. Instead of putting a yes there, I'm going to put an I for ionic. You should be learning to classify these. Lithium's a metal, phosphate's an anion, polyatomic. Is it soluble in water? If you look at your solubility rules, the answer is yes. It is soluble in water. All group 1 salts are soluble without exception. So let's do our dissociation. It's Li3PO4 because the phosphate's -1. Would free up 3 independent lithium ions and 1 phosphate ion. And so I would be equal to 4. The 3 lithiums plus the 1 phosphate. Calcium sulfate, metal, polyatomic anion. It's ionic. Is it soluble in water? The answer is no, it's not. The sulfate rule says that all sulfates are soluble except for silver, lead 2, mercury 1, and calcium, strontium, barium. I is not an issue here if it's not soluble, and I can't write a dissociation reaction for it. Let's look at aluminum perchlorate. Aluminum's a metal, perchlorate's a polyatomic ion. So yes, indeed, it is ionic. And one of the rules, like the second or third rule, says that all perchlorates are soluble without exception. So the answer is yes. In order to determine I first have to write the formula. Aluminum is +3, perchlorate is -1. So I would get 1 aluminum ion, and I would free up 3 perchlorate ions. And so I would have 1 aluminum plus 3 separate perchlorates, so I is 4. Let me just do a couple more of these and then we'll move on. I've got copper 2 iodide. Copper is a metal, iodide's a nonmetal. Metal with nonmetal is ionic. It is soluble because the rule says that all iodides are soluble with the exception of silver, lead 2, mercury 1. You don't have to memorize that. You have to be able to read that chart. When you're in pre-AP with me, in AP with me, I'll have you memorize it. So I would free up 1 copper 2 ion, and the 2 iodides would go their separate ways. Notice they're not forming iodine. These are ions swimming around, not forming elemental I2, but 2 separate iodide ions. And I have 1 copper ion, the 2 separated iodides, and I is equal to 3. Ammonia, ionic or covalent? Well, nitrogen's a nonmetal, hydrogen's a nonmetal. This is covalent. It is soluble in water, and the reason it is soluble in water is if you do the Lewis dot structure for ammonia, you see that ammonia is polar, like dissolves like. And here, though, what would be happening is ammonia, either as a gas or a liquid, depending on how we were delivering it, would become aqueous ammonia, but it doesn't break up into ions. If it is covalent and soluble, I is equal to 1. So molecular, we're going to look at a few words. There'll be a new one in just a minute. We would say molecular or covalent, or another way you may be seeing this is non-ionizing. Does not form ions. When you see these words, that communicates to us that I is equal to 1. Okay, I'm going to leave this at that. Methane is covalent. It is not soluble in water because methane is carbons and hydrogens, and if all we have are carbons and hydrogens, it's nonpolar covalent. Or you could draw the Lewis dot structure and see that it was the same thing all around the carbons. All right, so hopefully you picked up that concept. Let's look at some of the properties that can happen when things ionize. Okay, for one, we get electrolytes. That was merging a few words there. Oh, Dina. All right. What we find is that an electrolyte, when we form ions in solution, that substance has the ability to conduct electricity. And you'll understand why I have a bottle of Gatorade there in just a minute. Electrical conduction requires a pathway for the movement of electrons. Now, there's a variety of ways we can provide that pathway. If we have a metal, because of the sea of electrons, that will conduct electricity. But to be an electrolyte, we need something a little more specific than that. And what we need is mobile ions. And Gatorade is an example of an electrolyte. So soluble ionic compounds are considered strong electrolytes. If they're soluble, they form lots of ions and would conduct very strongly. And I will show you that. We'll have a lab where you'll see that conductivity. Strong acids and strong bases are also considered to be strong electrolytes because strong acids and bases, we saw earlier, go 100% to separated ions. Weak acids and weak bases only go partially, less than 100%, partially to ions, so they're considered to be weak electrolytes. They'll conduct, but very poorly in this. Now, I want to make a distinction here between what we call an electrolyte and other conducting materials. Metals, metallic compounds, they certainly conduct. And that's not what we're talking about here. We're talking about solutions that conduct. They're not dissolved. They're not considered electrolytes. They're considered conductive materials, but not an electrolyte. To be an electrolyte, we need ions that are, whoops, my Mimeo's jumping here, sorry, ions that are aqueous. Okay. Now, there are other substances that conduct as well. We have ionic substances that are pure, but only when they're molten. So ionic when they are melted, not solids, melted conduct electricity. But again, we're not talking about dissolved ions. So they're not considered electrolytes. Electrolytes means we're talking about ions that are also aqueous. So let's get an example of these. We have ammonium carbonate, NH4, and there's two of them, CO3. Ionic, acid or base, or covalent. You always have to classify. This is two polyatomic ions. It's considered to be ionic. Is it soluble? Yes. Okay, I'm going to qualify that a little bit. Is it a non-electrolyte or an electrolyte? It would be a electrolyte. We would form ions. So this is going to be an electrolyte, strong electrolyte. All right, copper 2 sulfite, CuSO3. It is ionic. That meets the first criterion, but it is not soluble. It has to be a yes in both of these columns to be an electrolyte. So the answer is it's a non-electrolyte. Barium sulfate. Look at your solubility rules for these. BaSO4, sorry about that. BaSO4, barium's a metal with an anion, so yes, it's ionic, but if you look at your solubility rules, it's one of the exceptions for sulfate that is not soluble. Okay, magnesium nitrate, MgNO3 2. Now, your solubility, it's ionic. Your solubility rules say that all nitrates are soluble without exception. So that's considered to be a strong electrolyte. Okay, let's do a few more of these just so we get the idea. And then we will move into our next video. Calcium chloride is CaCl2. It's a metal with a nonmetal. It's ionic. Yes, it's soluble. The solubility rule for chloride says that all chlorides are soluble with the exception of silver, lead 2, mercury, and 1. So yes, it's going to be an electrolyte. It's actually going to be a strong electrolyte. Hydrochloric acid, hydroic, came from ide, which is chloride. It's an acid. Acids are by definition in water, and since it's a strong acid, and you know that because you memorize it, it's considered a strong electrolyte. Ic came from ate, so that's from acetate, so it's HC2H3O2. It's an acid. By definition, acids have to be in water, but it's a weak acid, and therefore it's a weak electrolyte. So a weak acid is going to be a weak electrolyte. A strong acid is going to be a strong electrolyte. Methane, meth eats people's brains, CH4. It is covalent. It is not soluble. It is therefore a non-electrolyte. Ammonia. Ammonia is NH3. Now, this is information you don't quite know. So I'm going to tell you right now that yes, it's covalent, but ammonia happens to be a weak base. Our weak bases, we'll get a little glimpse into acid base, center on nitrogen. It is soluble, and because it's a weak base, it's going to be a weak electrolyte. But you know what? I would have to give you a little bit more information in the context of the question for you to have really known that. So that's new information. You should know that about ammonia now. Other substances, I would give you that information. Okay, that's it on electrolytes. So until I see you for solubility, this is signing off. I think all your coughing is behind me. We'll see how good my little microphone is at blocking that out.